Hi, welcome to my solution of the Capstone project for Udacity's Machine Learning Engineer from Microsoft Azure course. So let's switch into the Microsoft Azure machine learning environment. First, we import a lot of dependencies. Nothing very interesting there. We load our workspace from the config. Regarding the AutoML configuration, we first generate a compute cluster. To speed up the training a little bit, I decided for a standard NC6 GPU cluster, which was created here. Then for AutoML settings, we can see here, we then submit the experiment using experiment.submit. Here we can see the results from the run. It took about 20 minutes, and we get a best performing model with an accuracy of 82.1%. Here we can see the run details widget. The first run, which didn't actually fail, we can see it also here, had an accuracy of 82.123%. We then save the model file as a PKL and register the model for later deployment. So for deployment, we make an inference config pointing at the score.py file. The score.py we can see here. So we receive the data via JSON loads, convert it into a data frame, put it into the model to predict the result, and then return the result as a list. So here we see the deployment logs and the web service. I made a function predict from data frame to speed up the process a little bit and make it more easy. So we just put in a data frame and get the results back. We register a test data set we got from Kaggle, and then we predict from data frame and put in the data frame predict filtered. Get out the results to later submit it to Kaggle. We also save it as a CSV file. So here for a little more live show, we put in a data frame predict filtered the lines 1 to 10. We submit it to the data endpoint and get the data back. So here prepare the cell for a post request. We get the server's scoring URI from the web service, or here I also wrote it down. We don't need authentication as we have turned it to false. So in the header we just have the content type application JSON, and here's some exemplary data. So we have two records we put in, and then this is posted while requests post to a scoring URI with the input payload and the headers. So let's just do this live. And what we get back is the response text. That's 1-0 in this case. So the first person is a survivor. The second one, unfortunately, is not. And here we then can print out the service logs to see the request in a bit more detail. And here we can see the Titanic web service endpoint. That's so far how I went for the problem. Now let's have a look. What was the result? I uploaded it to Kaggle, and we achieved an accuracy for the test dataset of 73.4. So to finish up the project, I fill out a hyperparameter tuning notebook using hyperdrive. So in the beginning we import a lot of dependencies. We load the workspace and generate the experiment name, Titanic hyperdrive. And then we import the dataset. I generate the compute cluster and then choose for the early termination policy, bandit policy, to save some computing time. And I choose for two parameters, max depth and the learning rate. The gradient boosting regressor we can see here, which was imported from sklearn, and the entry script, which is the train py we just saw. So in the train py, we actually define our network. So the first step is, after we get the dataset in, to convert it to a pandas data frame, and then clean the data. After we use the fit method, we score the model with the x-test and y-test data. We start the experiment by submit and can see here the run details. So we performed a total of 40 runs and achieved a maximum accuracy of only 44.4%. Then we download and register our model. But in this case we won't deploy it, as the AutoML run has given us way better results.